The purpose of our project was to create a linkage mechanism that could swing a hammer.
We started our initial design using an iPad app called Force Effects Motion without a desk. And it was really useful because it allowed us to make our entire linkage system and dimension it, and then we were able to put a motor on it and make it move. We started with an initial 4-bar connected to this triangular piece, and it goes from CB to A to F here. Once we got it, we added a second linkage for our hammer because we wanted the angular velocity of our hammer to be higher than the angular velocity of the actual 4-bar here. So once we got that, we just added a driver dyad that allowed the hammer to move on its own. After we got that initial design down, we brought it to paper and we wrote it down and scaled it to the dimensions we needed. We also went to figure out the levels that we needed to make it work. So each link is not, so the links weren't hitting into each other, we have them on different levels. We ended up with 4 separate levels of links. Once we got that figured out, we went to the CAD.
We designed our model in SolidWorks, and then using that model, we created our links out of laser cut acrylic and assembled it using bolts and wooden pegs as our pin joints. As you can see, it moves as we designed it to.
While doing our CAD model, we analyzed our mechanism in MATLAB, and we drew our 3 loops and found our equations for position, velocity, and acceleration, and we allowed MATLAB to solve our equations. And as you can see, it takes a little bit of time to solve each equation, and after we did this, we found our plots, and also we used linkages. And here's that plot from linkages showing the shaking force and driving torque, and it worked out for the hammer that the max was when it was hitting on its downward motion. Here are the plots for links 3 through 8, the position, velocity, acceleration.